Alright, welcome to the next exciting installment of Year 11 Methods with me, Mr. Hannah. Okay, today we're looking at factorising, and we're going to be doing these things here to factorise expressions. We can remove the highest common factor, we can group terms cleverly, we can use the thinking about it method, we can use difference of perfect squares, which we learned a little bit about last time, or we can use completing the square. Now in this video we're not going to have time to cover completing the square, so we shall do that one last time. Let's maybe just cross it out for now. So we're doing that later. For now we're doing these four things here. Okay, first off is removing the highest common factor. So I'm sure you've done this before, so let's just do a quick example to, I don't know, refresh your minds. Let's go with 9x squared plus 81x. It's not my best 8. Okay, so both of these have a factor of 9 in them. You can divide 9 by 9, you can divide 81 by 9. We've also got a factor of x in them, because there's an x here and an x squared and an x here. So we'll take out 9x as the highest common factor. Now this term has 9x's in it, and this one has 9x's in it. So there we go, it is factorized. Let's try one more example. So let's have 2a squared minus 8ax squared. So see if you can find the highest common factor here. Hopefully you can see that it is 2a. First term has a lots of 2a. Second term has 4x squared lots of 2a. So there we go, that one is factorized also. Alright, next we've got grouping terms cleverly. Okay, this method's sort of a difficult one that you probably won't really use very much, but you need to know that it exists. Okay, so let's just do this with an example 2. So I can, actually let's make that x cubed plus 4x squared minus 3x minus 12. And what we're asked to do is to factorize this. So that's what we're doing, so factorize that is our question. Okay, so what we're going to do is group our terms cleverly so that we can find a highest common factor. So there's currently no highest common factor, but we're going to create a highest common factor by being a little bit clever. So let's group these first two terms together and the last two terms together. And I'll show you why in a moment. So there we go, and we'll subtract the last two terms, 3x. Because I took out the negative sign, this becomes plus 12. Okay, so now I'm going to take out the common factors from each side. So here we've got an x is a common factor for this one, so we'll take the x out. So the way that I knew to group these in such a way was so that I had common factors. So here I've got x squared lots of x and plus 4x of them. In fact, now that I look at it a bit more closely, I can see that I've actually got x squared as the highest common factor. So let me just change that. X squared. So it's good to know that mistakes are allowed. There we go. Alright, so there's x lots of x squared in x cubed and 4 lots of x squared here. Okay, now in this second part we can see that we've got 3 as a common factor. So we'll take the 3 out. 3 and x plus 4. Okay, now you can see we've got sort of two terms. We've got that's one big term, and this is another sort of big term, if you like. Now, what you notice is we have a common factor in these two underlined bits. Both of them have a factor of x plus 4. There's an x plus 4, there's an x plus 4. So we're going to take out the factor of x plus 4. So if we take out x plus 4, here we've got x squared, lots of them. So we've got x squared, lots of them here. And we've got minus 3, lots of them there. There we go. So now it has been completely factorized. So let's quickly go through what we did. We grouped things so that we had common factors. Then we noticed that there was a common factor between each. And so we were able to take out that highest common factor. Now, as I mentioned, you're not going to be using this method very often because it's a bit more difficult than all our other methods. It takes a bit of extra skill, I guess, in being able to identify common factors when there are so many different terms. So you can use it, but not really expected that you use it very often. Okay, next up we have my favorite method. It's called the thinking about it method. Okay, this one's good because you just basically have to think about it to know how to do it. So to start us off with the thinking about it method, we need to remember a result that we had from the last video, which is if you want to expand something that's x plus a times x plus b, you get the general result of x squared plus, first you add the two numbers multiplied by x, and then you times the two numbers a, b. So that's our general result that we learnt last time. So to get the middle term, you add a and b. To get the last term, you multiply a and b. So what the thinking about method involves is first looking at this last term and thinking which two numbers could a and b possibly be. So it might be easiest if we just do this using an example. So let's say we've got x squared. So by the way, we're going from this backwards to that to factorize. So let's say we've got x squared minus 2x minus 8. It's our first example. So what we're going to do, we're looking at minus 8, and we're going minus 8 must be a times b. And we'll think of all the things that a and b could be. Well, it could be 1 multiplying with minus 8, so it could be 1 and minus 8, oops, comma. Or it could be minus 1 and positive 8, or it could be 2 and negative 4, or it could be negative 2 positive 4. What else? That's everything. So those are our options for what a and b could be. Now we need to look at this middle term, and it's minus 2. Now we know that that middle term is a plus b. So we've got to look at these options and say which one, when you add them together, gives minus 2. Well, this first one, if we add plus 1 and minus 8, that gives us minus 7. So it's not that. Minus 1 plus 8, that's plus 7. So it's not that option either. 2 plus minus 4 is minus 2. So we know, let's get some colour. We know that it must be this option here, because when we add them, we get this middle term. So we can say that factorized, this expression is x plus 2 and x minus 4. Now if you want to, you can double check it by expanding that out. But I'm not going to because I'm confident. Okay, so maybe I should do one more example using the thinking about it method. So let's let's go with example 2. Okay, let's suppose we have x squared plus 5x plus 6. Okay, it's a fairly easy one. So look at the plus 6, things that make plus 6 could be 1, 6, could be minus 1, minus 6, could be 2, 3, or it could be minus 2, minus 3. Okay, so now we look at the plus 5. So when we add these together, which one gives a plus 5? Obviously, it's this one here, the positive one, 2 and 3. So it must be x plus 2, x plus 3. Now if we change that exact same example to x squared minus 5x plus 6, you can see there's plus 6 again, so we've got the same examples, but this time with the minus 5, it's actually going to be this last option. So that one is a little bit different, which is x minus 2, x minus 3. And we could, if we wanted to, do a third example which also has the 6 and go maybe minus 7x plus 6. So we've got that same plus 6 again, so it's the same set of 4 possibilities, but with the minus 7, you can see it must be the minus 1, minus 6 option. Equals x minus 1 and x minus 6. So the more of these type you'll do, the better you get at it, and you'll actually find that you possibly quite enjoy it, because it's kind of fun after a little while, after some practice. Okay, last up we've got difference of perfect squares. This one relies on the knowledge that we had from last time, that we have the general result of whenever we have x plus a times x minus a, our answer is x squared minus a squared. So once again we're going to go from this backwards to that. So just to make life perhaps a teeny tiny bit easier for some people, I'm going to write the exact same thing backwards. X plus a, x minus a. There we go. So it's the same thing written in the other direction to make life a tiny bit easier for ourselves. Okay, so let's. You've looked at a couple of examples already from last time, so we'll start off with an example that's not. That's maybe not 100% easy. Okay, so let's look at 3x squared minus 75. And our job is to factorize that. Well, the first thing you notice is it's not in this form here. So what we're going to do first is our method 1, remove the highest common factor. So we'll do that first, and we notice that 3 is a factor, x squared, and there are 25 3's in 75. Okay, so now it does look like this. So I'll write it out again to make it really obvious for everyone that 25 is actually 5 squared. So here our a is 5. And now we can just finish it off using our formula. So the 3 is still there. We've got x plus 5, x minus 5. There we go. That one's done. So let's do another example. Example 2. Let's see. Okay, example 2. Let's do 9x squared minus 16. Okay, so there's a couple of tricky things going on here. You might be tempted to do this again, but you notice that you can't. 9 does not go evenly into 16. So there's two different ways to do this. I'm going to do the first one here and the second one over here on the other side. So first, I notice this is a perfect square, so that's 16 is 4 squared. And 9 is actually a perfect square as well, it's 3 squared. So I could change 9x squared into 3x all squared. So you see how that's the same? And I'm changing my 16 into 4 squared. So now it does look like this, but my x is 3x, my a is 4. So wherever I've got x, I've got 3x, and a is 4. So that one becomes 3x plus 4 multiplied by 3x minus 4. So there we go. Option 2 is you can still take out 9 as a common factor if you want to. It's just going to involve some fractions now. So now it's going to be 16 divided by 9. Okay, so now this actually is a perfect square, but a fractions one. It is 4 over 3, 4/3 squared. Okay, so for people that don't like fractions, well, firstly, you're just going to have to get used to them. But this may not be your preferred method. Okay, so now whenever we've got a, we've got 4 on 3. So 9 out the front would be x plus 4 on 3, x minus 4 on 3. There we go. And the astute among you will notice that this is the same as this. They're actually the same. And I guess you can test that with your calculator later on if you don't believe me. Alright, one last example. Okay. Example 3. This one will possibly be the trickiest so far. Let's go x minus y squared minus 16y squared. Okay, so this one is a perfect square already. So instead of just x squared, we've got x minus y squared. So our x is x minus y. And 16y squared, we're going to do similar to what we did here, and change 16y squared into 4y all squared. This bit we can leave the same, x minus y squared. So now this is like our x, this is like our a. So we can use our difference of perfect squares formula. Whenever there's an x, we're writing x minus y. Whenever there's an a, we're writing 4y. X minus y plus 4y. X minus y minus 4y. And now it's just a matter of simplifying this down. X minus y plus 4y is plus 3y. X minus y minus 4y is x minus 5y. There we go, we are done. So there are 4 main methods of factorising. There's still completing the square, which we will come to later. Okay, it's been a big bit of work, so good luck doing the textbook work now. See you in class.